Video, I will be talking about how to solve for unknown variables. We're going to be doing a little bit of evaluating one-step equations and multi-step equations with distributing in it, x's on both sides, all those algebraic equation solving questions you may have. All right, so when we're evaluating an expression, okay, this is where we're going to substitute a number in for our unknown variable. So in the expression 2x plus 5, our unknown variable is x. Okay, that's our placeholder until we know what x is. But in this case, they tell us what x is. Okay, so x equals 3. So everywhere that I see an x in my expression, I am going to put a 3. Now I have to keep in mind, put it in parentheses. Why? Well, if it's supposed to be multiplication like it is in this particular question, 2 times x is multiplication, I need to have it in parentheses to note that. Or if it's a negative number, so that it doesn't run into the rest of the problem and we do the proper operations assigned, we should always get in the practice of putting our inserted value in parentheses in our expression. All right, and then the last step is just applying PEMDAS. Now it turns from an algebraic expression into a numeric expression. So PEMDAS works with no problems. All right, let's do some examples, and you practice along with the examples and see if you can do it. All right, so now let's do some examples of evaluating expressions. Okay, so the first one I want to do is when I have the expression x plus 5 where x is equal to 3. So this means everywhere I see the unknown variable x, I'm going to put a 3 in it. And when you put it in, you want to put it in parentheses. That way it stays separate until you can identify what negative and positives you have, what operations are around it, and you can discern how to do this. As I can see, don't really need the parentheses here. I've evaluated, I don't need a parentheses. I can drop them and just add my two numbers, and the answer is 8. All right, let's do one a little bit harder. Okay, example 2 we're going to do a lot with. So when in example 2, I have this expression, and I want to evaluate it where x equals 7, where x equals -3, and where x equals 1/2. So let's start with 7. So I do these one at a time. Okay, the first time I'm going to insert 7. So again, put it in parentheses when you insert it, okay? And I can see here that I do need the parentheses because the parentheses are enacting multiplication here. Right here, the 2 was being multiplied to the x. So now that I've put 7 in for x, 2 is being multiplied to the 7. So I have to keep those parentheses. I could change it to a different symbol that means multiplication, but in this case, parentheses are fine. I'm going to use them. All right, so this is 2 times 7, which is 14. Drop down my -10. And then my answer will result in 4. All right, let's do where it's -3. So this time I'm inserting a -3 in for x, okay? So I put this -3, boop, into my unknown because I know that x equals -3 in this situation. Got to evaluate whether or not I need those parentheses because first I keep it contained. I do. Still means multiplication. On top of that, I have a pesky little negative. It's probably best keep it in those parentheses. So my first step in my PEMDAS is to do my multiplication here. So I have 2 times a -3, which is going to be a -6. All right, now that I've got multiplication out of the way, let's do our subtraction. I have a -6 minus a 10. That is going to give me -16. If you're really confused on what I did here, you need to go watch a video on order of operation, or PEMDAS, and operations with integers. Okay, that's your negative and positive numbers. Okay, so when we evaluate, we get a 16, a -16. All right, so let's evaluate the 1/2 now. So this time, Wherever I see an X, I'm going to plug 1/2 in it, and I'm going to put that in parentheses, which it's applicable again here too because of that same multiplication that I'm doing in this problem. Okay, so 2 times 1/2. Got to put a 1 underneath my 2, multiply across the top, get 2, multiply across the bottom, get 2, minus 10. A 2 over 2 equals a 1 minus 10. 1 minus 10 is a -9. If you had some problems on this step here, you need to go watch a video on operations with fractions. But this video, all about equations. We're not going to go back and do those smaller skills, but that's what you need to search. All right, awesome. So we know how to evaluate, and this is important in the checking process of equations. So let's go ahead and look at an equation real quick. All right, so what is an equation? We just talked about evaluating expressions. I have a video on combining like terms which talks about what an expression is if you need to go back and look at that. But now we're really going to talk about the meat and bones of what an equation is. Okay, so I have this example here of 2x plus 3 equals 6. Now, an equation is something that shows equality. This is saying 2x plus 3 is equal in value to the number 6. Okay, so we have already been working with equality in other ways, and this is no different. Even though one side looks different to the other, they're equal. So let's look at some examples of equality real quick. All right, so we have the problem we just did. 2x plus 3 is equal to 6, which means the 2x plus the 3, even though it looks different, is the same value as 6. Just like 12 inches, even though that looks different than 1 foot, they represent the same amount of distance. Or 2 dimes and 1 nickel equals a quarter. They look different. Over here I have nickels and dimes, and over here I just have 1 quarter, but they represent the same value of money. All right, so when we do this, we have to do opposite operation, okay? And I'm going to talk about in the examples what that is, but let's talk about it a little bit here. The opposite of adding would be subtracting, okay? If I want to undo adding, I have to subtract. So if I have a 5, to undo that 5, if I have 5 plus x, I would have to insert a -5 to get a 0. And what we're trying to accomplish when we're solving an equation is solving for that x. So I need to be able to get a 0 so that it goes away and x is by itself. All right, the other thing we have to do, we have to realize is that this equation shows equality. So whatever I do to one side of the equation, I have to do the other side equation. So if I'm undoing adding by subtracting, I got to do it to both sides, okay? So the opposite of adding, subtracting. The opposite of subtracting, adding. Opposite of multiplication, division. The opposite of division is multiplication. And I'll show you more the beauty of that pattern when I do some examples. All right, always check your answer. We can do that by using the skills we learned in evaluating expressions by substituting it in for the unknown. So we'll look at that in our examples as well. All right, so let's get to those examples. Try them along with me and see if you can do it. Let's look at the parts of an equation. So in this equation, I have the variable, this variable here, x. I have 3 different terms, and if you're having problems with this, go look for identifying that you have 3 terms. You need to look at a combining like terms video. Okay, so I have 3 different terms. I have 2 constant terms. I have a 3 and a 10, which are constant, and a coefficient of 2. This is saying that the weight of 2x plus 3 is equal to the weight of 10. Okay, they're equal. That's what the equal sign means. Because there is an equal sign in this problem, whenever I solve for x, I'm going to have to keep in my mind, okay, what I do to one side got to be equal and do it to the other side. If I have 2 dimes and a nickel, and I say that's equal to a quarter, if I take 5 away from this side, 5 cents, they're no longer equal unless I also take 5 cents away from my quarter, which would break it down into 2 dimes or 4 nickels or 10 pennies. I have to keep it equal, or that equal sign is no longer true. It becomes false. So what I do to one side, gotta do to the other side. So let's do some examples of that. All right, so our first example here is going to be x plus 5 equals 10. So the first conversation I need to have is the two O's, opposite operation. So a lot of you probably already know this. We need to figure out the opposite. And when we're thinking about the opposite, we're thinking about what's going to get rid of it. So in adding, to be able to get rid of a 5, let's say I have a 5, how do I make that 5 a 0? Because that's getting rid of it in adding and subtracting. Well, I would have to subtract that positive 5. So the opposite of adding would be subtracting. And if I had a negative 5, the way to make that a 0 would be to add 5 to it. So the opposite of subtracting is adding. Now in multiplication and division, it's a little bit different. To be able to get rid of something, you want to get a value of 1. Okay, so if I have a 5 and it's being multiplied to an x, the way to get that 1 is divide it. Okay, remember this fraction bar means division, because 5 over 5 is a big old fat 1. So the opposite of multiplication is division. The same thing if I'm dividing the x by 2. If I multiply it by 2, these cancel and give me a big fat 1. I have a 1x. So the opposite of division is multiplication. All right. So I got to keep these rules in mind when I'm trying to solve for x. The other thing I have to keep in mind when I'm solving for an x is what is everything doing to x. Now, you can do this in any order that you want, okay? When we undo equations, we don't have to follow order of operation, all right? Because we're undoing everything around x. I suggest, though, for the purposes of keeping your math really neat and clean, start with adding and subtracting, then go on to multiplication and division. So ask yourself, is anything being added or subtracted to the x? Well, the answer is the 5 is being added. It's x plus 5, so 5 is being added to the x. I look at its opposite operation and I say I got to subtract. Now on the last side, when I was talking about what an equation is, we talked about equality. What I do to one side, I have to be equal and do it to the other side. Now notice something. I'm not subtracting 5 from x, just from the 5. And that is because when you add and subtract, something has to be like. It can only be with like terms. Okay, we learned that in the like terms video I did. But when I multiply and divide, I don't care about what's like. I don't need like terms, okay? So I don't have to, when I multiply and divide, I have to do it by everything. And when I add and subtract, I only have to do it by the like terms on each side. So positive 5 minus 5, that gives me the 0 I'm trying to get. Okay, so it just dropped down my x. 10 minus 5 is 5, so 5 equals x. Now I got to check. Got to check my answer. Okay, so just like in evaluating, I start with my equation. And my equation says that x, every time I have the unknown x, it equals 5. Now, our goal is to get two equal sides. So I do this adding, it's 10. And that is equal to the other side 10. I have a true statement here, so my check works out. All right, so let's do another one. Let's do my second example, which is x minus 3 equals 9. Okay, so my opposite operation, I first look for anything being added or subtracted to x. I see I have x minus 3, so the 3 is being subtracted from x. The opposite operation of that would be to add. And I got to do it to both sides so that I'm fair. This will give me my required 0, drop down my x. 9 plus 3 is 12. All right, now I got to do my check. Got to insert the 12 into the unknown number. 12 minus 3 is 9. 9 does equal 9, so it checks. Awesome. Let's go ahead and do example 3. All right, so example 3 is a little bit different. Okay, this time I have nothing adding or subtracting to the x, but I do have something multiplying. The 2 is multiplying the x. So I asked myself, what is the opposite operation of that? And that is division, because I'm trying to acquire a 1. Okay, 1 over 1 turns, 2 over 2 turns into a 1. Got to do it to both sides because of equality, that equal sign. All right, so now I just have the x because I got the required 1. That makes it disappear. Because 1 times anything is itself, right? So it doesn't matter. 2 goes into 12. Remember, this means division. Goes into 12 6 times. Now let's do our check. All right, I'm going to insert insert 6 into the x in order to evaluate. So I got to put that in parentheses. They are needed in this one because that means multiplication. So 2 times 6 is 12. 12 does equal 12. It checks. All right, so in my next example, we are going to do, hold on a minute, let me grab a pen. I have a little bit of a mistake here. Oh, no, I don't. Okay, never mind. I'm going to do x divided by 5 equals 2. Okay, so no adding or subtracting. Let's go on to our multiplication and division. Okay, so the 5 is dividing the x. The opposite operation of dividing is multiplication. Got to do it to both sides. They cross out, giving me the desired 1, so I just have an x. 2 times 5 is 10. All right, so those are my one-step examples. Let's go on to some multi-step equation examples, and we're going to start out with example 4, which is 2x plus 5 equals 33. And I'm sorry, I'm going to jump back to the last one because you know what we forgot to do? We forgot to do a check. Let's do a check real quick. Okay, so let's insert 10 into the equation. Okay, so I'm going to put 10 in for x, put it in parentheses. I see I don't need the parentheses, so I'm just going to ignore them. 5 goes into 10 2 times. 2 equals 2. It checks. Now let's go on to our multi-step equation. All right, so remember I said look for things that are adding and subtracting first, and wouldn't you know it, 2x plus 5 means the 5 is adding to the x. So to get my needed 0, I'm going to subtract 5 from both sides because it's equal sides. All right, that's going to give me my 0, so I have a 2x. 33 minus 5 is going to give me a 28. All right, now I still got a number tied to that x, so I can't say x equals 28 because it's 2x equals 28. So I got to get rid of the 2. So I look at the 2 and I say, what are you doing to the x? And it's multiplying it. So the opposite of multiplication is my division. Got to do it to both sides. Got to be fair because it's an equation. And x equals 14. So let's go ahead and do a check. So I'm going to evaluate it when x is 14, which means I'm going to put 14 in for x. All right, so 2 times the 14 is 28. 28 plus 5 is 33. And yes, 33 does equal 33. It's true, it checks. And if you're in one of my classes and we haven't gotten to multi-step equations, please stop this video. You can watch the rest after we learn it. Okay. All right, again, we got to ask ourselves, is anything adding or subtracting to the x? And the answer is yes. The 10 is subtracting the x. So to get our required 0, we have to add 10 on both sides. That gives me my 0 here. 3x equals 21. Next, I asked myself, what is that 3 doing to the x? It's multiplying, so my opposite operation would be to divide. That gives me my required 1, and 3 goes into 21 7 times. Now let's do a check. I insert the 7 everywhere I see an X. All right, so 3 times 7 is 21. 21 minus 10 is 11. My equation checks out. I know I got the right answer. All right, let's add some division in there. Okay, so the first thing I asked myself, is there anything adding or subtracting the X? We have a true statement here of a positive 3, so I want to subtract 3. Because it's being added to the X, I'm going to subtract it so I get my required 0. And when I subtract the 3 on this side, I get a 10. All right, there are two ways I can look at this. I can either say X is being divided by 2, because technically it is, or I can say X is being multiplied by 1/2, okay? Either way, you're going to get the right answer. If you're saying it's being divided by 2, you're going to multiply by both sides by 2. If you say it's being multiplied by a 1/2, you got to divide both sides by 1/2. You're still going to get the same answer. I'll show you why. Anything over itself is a 1. So I got my 1 here. Let's rewrite this because it looks ugly. 10 is being divided by 1/2. Now I know that when I divide my fractions, it uses keep, change, flip. So I keep the first one, throw a 1 underneath the whole number, makes it a fraction. So I keep this first one, I change division to multiplication, I flip the second fraction. Now that it's multiplication, I can just multiply through. And if you're wondering, how in the heck does this work? This doesn't make any sense. Look up a video on dividing fractions. I might even have one, I don't know. All right, so I multiply across. 10 times 2 is 20. 1 times 1 is 1. Anything over 1 is being divided by 1, so it's just itself. The answer is 20. Now we need to do a check. Let me make some room for a check. So everywhere I see an X in my equation, I need to put a 20 in. So I'm going to insert 20 into my X and see if both sides work out right. Okay, so that I can multiply these fractions, I got to put a 1 under the 20. 1 times 20 is 20. 2 times 1 is 2. Now I got to reduce that fraction. So 2 goes into 20 10 times. 10 plus 3 is 13. It checks. So I know I did it right. Let's go on to the next one. Feel free to pause these if you need to. I know I'm going kind of fast, but it's so that it uploads quicker. All right, let's do the next one. And remember, if you're in one of my OutSchool classes and you're watching this required video, you can email me if any of these do not make sense, and I can explain it again in a way that your mind understands it. So don't feel like if you don't get it that it's the end of the world. Just email me. Okay, first thing, ask myself, anything being added or subtracted to X, I have something being subtracted. So the opposite operation would be add, and I have to do it on both sides because it's an equation. And I added a 5, which made no sense. So if you're sitting there saying, hey, Miss Red Miles, you're doing it wrong, you get the gold star for the day. You're right, I was doing it wrong. It should have been a 6, not a 5. This is going to give my required 0. If I add 6 to 8 to 12, I'm going to get 18. I almost gave you the answer there. All right, so let's look at this like we're multiplying a 13. Well, we did that last time. Let's look at it like we're dividing a 3. So how did I get that I'm dividing for 3? Well, first thing I do is I multiply my fractions. Okay, X times 1 is X, right? Anything times 1 is the other number. 3 times 1 is 3. Okay, so now I look and I have division. So the opposite of division is multiplication, so I have to multiply both sides by a 3. All right, this is going to give me my 1. Over here, I'm going to get a 54. Okay, so my answer is 54. Let's do a check. All right, I'm going to put my 1 underneath my 54. So if I multiply those fractions, I have 54 over 3. Let's go ahead and reduce this. If I reduce it, I am going to get 18. 18 minus 6 is 12, which does, it's true, it equals 12. 12 equals 12. Very good. Okay, let's stop there. Go ahead and watch the next video. Go ahead and watch the next little bit, and then I'll do some more examples. If you are in one of my OutSchool classes and we haven't gotten to X on both sides or distributing, please stop. I probably made this for an accelerated class. That's why all the steps are in here. So if you're in one of my slower 8-week or 10-week classes, please do not watch the whole video until we get there. All right, so sometimes we'll have x on both sides of an equation. As long as it's the same value, they can be combined. If you need help with this, go back to my video on combining like terms. But we are going to combine on both sides of the equal sign. So now that we have an equal sign, we have to be equal. When we move things, we got to use opposite operation. We have to do the same thing to both sides. I'm going to show you a shortcut on how to do that. But just remember, this is putting everything together. Our solving equations, our combining like terms, get our x by itself, always check your answer. So now, let's do a few examples. Follow along with me, and let's look at the patterns of x's on both sides. So let's look at examples of when x is on both sides of the equation, and I have 2 that I want to go over. So example 1 will be x plus 6 equals negative x minus 2. Now we can use opposite operation to move my variables to the other side, okay? So if I want this x to go to the other side, right here it's negative, to make it disappear over here I have to make it positive. Whatever I do on one side I have to do to another side, and I can only add to like terms. So I'm going to add this x over here. Okay, so negative x plus x gives me 0, goes away. Now I have 2 x's, because this is 1 plus 1, plus 6 equals negative 3. Now this looks like something I've seen before. Now I can start the process of opposite operation as it pertains to x. Okay, so the 6 is being added to the x, so I'm going to subtract it on both sides. It's going to be 2x. This becomes a 0. Negative 3 minus 6 is a negative 9. This is being multiplied, so I divide on both sides. And my answer is x equals negative 9 over 2, or I could say that is negative 4 1/2, or I can say it's negative 4 1/2 this way, negative 4.5 and negative 4 1/2. They all say the same thing. Okay, now I'm going to show you another way to do this. There's a quicker way. It's basically this way, but it's just quicker in its style. So it's doing the same thing. It's bringing the x to the other side, okay, and then it's bringing the 6 to the other side, but it's just a quicker way of applying those rules. And what it's called is the railroad tracks. Okay, so you got to decide what lives on this side of the railroad tracks and what lives on this side of the railroad tracks. When you change the side you live on, you have to change your sign. So if you're negative, you become positive, and if you're positive, you become negative. I'm going to say that the x's live on the left-hand side of the railroad tracks, and the constant terms live on the right side of the railroad tracks. Okay? So this x stays here. It doesn't change signs, so it retains its positive sign that it has here. This negative 6 has to go to the other side. This positive 6 has to go to the other side. It's positive right here, as you can see. Oh, but it's going to cross the railroad tracks, has to change the way it looks, so it becomes negative. Right over here I have a negative x and a negative 3. The x has to come to this side. When it comes over, it changes its sign to a positive x. This 3 is going to stay right where it is, so it just doesn't change its sign, and it's just a negative 3. So x plus x is 2x's, and negative 6 minus a 3 is a negative 9. See, we're already down to this step. Okay, to get multiplication away from the x, I have to divide both sides. And again, x equals a negative 9 over 2, or a 4 1/2 negative, or a negative 4.5. However you want to write it, that's what it equals. Very good. Let's do example 2 both ways. Does not matter which way you like to look at it because they're both actually the same way. One just gives you the railroad track story. If you need a big story to help you, that's what that does. But it's really doing the same exact thing we do, doing it the mathematical way. So you decide. All right, to move this 3 to the other side, I have to get a 0 over here. Okay, anytime I move something, I got to get a 0. So, unless it's multiplication and subtract, but I'm actually taking and subtracting a whole term. Now we'll get rid of it completely. That becomes just completely 0. And I got to subtract it from the like term over here, which is going to give me a negative 1x minus 3 equals, all that's left over here is a 6. Okay, this looks like what I know. Look for adding and subtracting. I have the 3 being subtracted. Got to add it. So now I have a negative 1x equals 9. Okay, the negative 1's being multiplied to the x, so I'm going to divide it from both sides. All that 1 does is turn the 9 negative because it's a negative 1. And my answer is a negative 9. Okay, let's do it the railroad track way now. Draw my railroad track. Okay, 2x stays over here because I'm not switching. I'm not going to change the sign. But I am going to bring the negative 3 over here, and it's going to become a positive 3 because it crosses the railroad track. This is going to cross the railroad track so it can be combined with the like term of 2x, and when it does, it becomes a negative 3x. This 6 is going to remain where it is, so it doesn't change its sign. 2x minus 3x is negative 1x, and 3 plus 6 is 9. Still got multiplication tied to that x, so I'm going to divide out a negative 1, and x is going to equal a negative 9. They both worked out the same. I can also check my answer by substituting in the negative 9. So everywhere I see an x, this time I have 2 places that I have an x. And in both of them, I'm going to put a negative 9. See, negative 9 in parentheses, negative 9 in parentheses. Now let's get rid of our multiplication because we're doing order of operation because it's a numeric expression. 2 times the negative 9 is a negative 18 minus 3 equals 3 times a negative 9 is going to be a negative 27 plus 6. Negative 18 minus 3 is going to give me a negative 21. Likewise, negative 27 plus 6 is a negative 21. Both sides are the same. It checks. The last thing we need to know to be able to button this all up is when there's distributing. Okay, again, if you have any problems, go back to my combining like terms video. I really take a good long time to talk about distributing. We'll do it here too. Distributing is just when you multiply the outside number to everything inside the parentheses. Basically, you're treating that parentheses instead of do me first in PEMDAS, we jump it down to the multiplication step and we do it. So next we're going to look at some examples of this. Just remember, you need to know your rules of distributing. You should know already how to combine like terms, apply opposite operation, get x by itself, check your answer. So let's do some examples and be sure to do them along with me and see if you can do it. Now that we've talked about distributing, let's talk about some of the examples of distributing. So let's go with example 1. All right, so in example 1, I have 2 times the quantity of x minus 3 equals 3 times the quantity of x plus 2. So the first thing I need to do is distribute my factor through. So it's going to be 2 times x and 2 times a negative 3. Bring down my symbol, 2 times 3. Bring down my equal sign, distribute this 3 through, and I get 3 times an x. Bring down my sign, 3 times 2. Okay, so I did my parentheses. I'm on to my multiplication. So 2x minus 2 times 3 is 6. 3 times x is 3x. And then my 3 times my 2 is 6. All right, so pick whichever method you like to get your combining like terms on both sides together. So we learned how to get x's on 2 different sides together. Now we have to do it in this problem as well. So I'm going to subtract 3 and bring it over here. Okay? If I subtract 3 from both sides, I get a 0 there, which is what I wanted to accomplish. And here I'm going to get a negative 1x. Okay, now this is subtracting the x. This negative 6x is subtracting from the x, so I'm going to add it to both sides. That will give me the 1 I need here, the 0 I need there, sorry, and then 6 plus 6 is 12. The last step is to get rid of this pesky negative 1. It's being multiplied, so I'm going to divide it out. And x is going to equal a negative 12. Now let's go ahead and check that. So my expression is 2 times the quantity of x minus 3 equals 3 times the quantity of x plus 2. And I'm inserting a negative 12 into my x's. And I have to do it to each x. Okay, I can see the parentheses are not really needed in this one, so I'm going to get rid of them. They're a little bit confusing in this one because it doesn't represent multiplication or double negative. I don't need them. So I do what's in the parentheses first. So a negative 12 minus 3 is a negative 15. Negative 12 plus 2 is a negative 10. Okay, now I'm going to do my multiplication. That's going to be a negative 30. And look, this one's going to be a negative 32. So it checks out. We're all good. I can move on to the next example. Okay, so let's do example 2. And that is negative 2 times the quantity of x plus 6 equals negative 5 times the quantity of x minus 3. Okay, again, I got to distribute it through. Okay, that means multiplying by everything in the parenthesis. So negative 2 will be multiplied by x. Drop down my operation. Negative 2 is going to get multiplied by 6. Drop down the equals. Now negative 5. And remember, you got to take that negative with it. And it gets distributed by everything in the parenthesis. So a negative 5 times the x, drop down my subtraction, negative 5 times 3. All right, now I got to do the next thing on PEMDAS. I did my distributing with my parentheses, no exponents. Now I'm on to my multiplication and division. Negative 2 times x is a negative 2x. Don't overthink it. Negative 2 times 6 is a negative 12. Negative 5 times x is a negative 5x. Negative 5 times 3 is a negative 15. Now I need to clean up some of these symbols. So when I have an addition and a subtraction symbol side by side, that becomes subtraction. And when I have 2 negatives side by side, that becomes addition, okay? And that has to do with your rules. Go back to order of operation and integers to get those rules. You need to look up a video about order of operation and a video about working with integers if that confuses you. Okay, now I got to get everything on the right sides. So I want to bring this negative 5x over here. It is being subtracted in this problem, so I'm going to add it. And I can only add it to the like term on this side. Okay, that's going to give me the desired 0. Over here, I'm going to have a positive 3x when I do this math. Minus 12 equals 15. Okay, so the negative 12, that means it's subtracting my x, so to move it, I got to add it to both sides. All right, and I'm going to continue up here because I ran out of room. This is going to go to the desired 0, and it's going to equal 27. Last step is getting the 3 away from the x. It's multiplying the x, so I'm going to divide it from both sides. It's going to give me my desired 1. Remember, with multiplication division, the desired number is to get a 1 because 1 times anything doesn't change the number. In adding and subtracting, we desire to get a 0. And the reason for that is because adding or subtracting a 0 to anything doesn't change the number. Let me give you a little side context. 2 times 1 is still 2. 2 plus 0 is still 2. So it doesn't change the original number. We don't want to change the x. We just want everything away from the x. So anything being multiplied or divided, we want to get a 1. Anything being added or subtracted, we want a 0. So 3 goes into 27 9 times. So now let me get a new page and we're going to do the check for that one. So we got 9 as our answer. Let me just double check that. We did get 9, right? Yes, we got x equals 9. So I'm going to put x equals 9. Everywhere that I see a 9, everywhere that I see an x, I got to put that 9 in. And I got to put it in parentheses until I evaluate if I need it to mean multiplication or if there's a negative and I just want to keep it pretty from that negative. All right, order of operation says I do what's in parentheses first. So 9 plus 6. Don't really need these parentheses. I'm going to ignore that they're there. And 9 minus 3 is going to give me a 6. Okay, so negative 2 times 15 is a negative 30. Negative 5 times 6 is a negative 30. It checks. We are ready for our last example of this video, which is example 3. And that is negative 1, x minus 2 equals an x, negative x plus 15. Okay, so let's have a conversation. What do I assume is here if nothing is here? Well, just like when you're looking at 2x plus 3x, that means I have 2 x's and I have 3 x's, which means if I count them all up, I have 5 x's, and all I had to do was add the coefficients and get that same answer. Same thing applies here. If I have this, then I know I have my 3 x's over here, but what do I have here? Well, I can plainly see there's only 1, okay? And they don't write the 1 because it's redundant. You can see that there is 1x there, okay? That's the same idea here. If I have no number here, I can assume it's a 1. They just didn't put the 1 there because it's redundant. I can see there's one quantity of negative x plus 15, so why put a 1 there? But for the purposes of our math, we want to put a 1 there so I know that I distribute a negative 1 through. Now you see this first one, they put it in. All right, so I'm distributing my negative 1 through, which just means I'm multiplying a negative 1 by everything in the parentheses, by the x and by the 2. All right, bring my equals down. Now I'm going to do the same thing. I'm going to bring through another negative 1. So negative 1 times a negative x this time. Bring down my plus or my positive, however you want to look at it, and I have a negative 1 times 15. Negative 1 times x is a negative 1x. Negative 1 times 2 is a negative 2. Negative 1 times a negative x is going to give me a positive 1x, okay? Plus negative 1 times 15 gives me a negative 15. I got to clean up these signs. So negative 1x, two negatives make a positive, and a positive and a negative make a negative. All right, let's get those like terms together. In order to get a 0 so that this can move to the other side, I have to subtract it. Gives me my 0. And this is going to give me negative 2x plus 2 equals negative 15. Let's move it to up here. All right, this is being added to the x, so I'm going to subtract it to move it. And this is being multiplied to the x, so I have to divide it to move it. And negative 17 over negative 2 is going to be a positive 17 over 2. The two negatives make a positive. So I can write it this way. I could write it as, well, 2 goes into 17 8 times with 1 left over, or I could put 8.5. Those are all correct answers. They all mean the same thing. They have the same weight. Okay, I hope you enjoyed this video. Please check out places that you can see my classes. I have a link to it on the next slide.